Let us start. So last time we were discussing about the biomedical instrumentation. That is the title of the unit number 1. So we have discussed all these things, biomedical instrumentation, clinical instrumentation, research instrumentation. We have discussed this last time. Importance of biomedical instrumentation, this was discussed. Basic objectives of biomedical instrumentation: information gathering, diagnosis, evaluation, monitoring, and control. This was also discussed. Okay, these systems we have discussed, various types of systems in our body. It is just to make you aware of various terminologies. Okay, I think, yeah, last point was classification of biomedical instruments. So we have discussed some of the instruments last time. Okay, I think this was the last point where we stopped the different types of biomedical instruments. Okay, now let us proceed. I want to keep my watch in front of me so that I am aware of the time. Okay. So classification of instrumentation system. Now this point also we have discussed last time: clinical instrumentation and research instrumentation. So clinical instrumentation means the equipments which the doctors or nurses are using directly, right? Whereas research instrumentation means the electronic equipments which are used for medical research. That means to acquire more knowledge, to find out newer things in the area of medical field, the type of equipments being used. So that comes under research instrumentation. Then next, the type of measurements which are carried out using these instruments, there are two types, called as in vivo measurement and in vitro measurement. So let us see what do you mean by this. So in vivo measurements means the measurements which are made on or within the living organism. So the measurements which are made on or within the living organism. So those are called as in vivo measurements. For example, a device or the needle, when it is inserted into the bloodstream to measure the PF. So directly the needle is inserted in needle or any instrument, it is, or the device which is inserted inside of the body to measure pH of the blood directly. So that is called as vivo measurement. The second type of measurement, it is vitro measurement. In vitro measurement. Okay, so in vitro means the measurements which are made outside of the body. Measurements which are made outside of the body. So in this case, we take some sample. We take some sample of, for example, if it is a blood. So from this sample, then the analysis is made in the lab. So this is how the instruments are classified as in vivo and in vitro instruments. Okay. Now, a conventional instrumentation system, when we talk about, inside this block diagram, you will have some electronic, many electronic instruments, the blocks having different functionalities. Now, for this instrumentation system, we give some input. Now, there may be more than one inputs or the combination of inputs, and the various electronic equipment inside this block having different functionalities, they will sense these inputs and they will establish the relationship between inputs and outputs. And many outputs will show wide range of responses to a given set of inputs. So that is in general what we call as the instrumentation system. Okay. Now in medical field, many times we talk about man instrumentation system, because in case of medical instrumentation system we must consider man also, because the man or the human being is involved there. So that's why we call this as man instrumentation system. So this makes this type of instrumentation, it is this is how this type of instrumentation system, it is different as compared to the conventional instrumentation system, because a human being is involved in that. So that's why it is called as man instrumentation system. Okay, human being or any living organism. So it is a combination of human being and the instrumentation. That means the electronic equipment. So that's why we call, in general, we call it as man instrumentation system, which is used to measure various parameters related to human being. Okay. So it attempts to measure and understand the internal relationship of human body organs. It helps the medical clinician or researcher for obtaining reliable and meaningful measurements from human being. So the primary purpose of many man instrumentation system is to help the clinicians and researchers to obtain reliable and meaningful measurements from a human being. The concept of man instrumentation system is applicable to both clinical as well as research instrumentation. So in the earlier slide, I have explained you what do I mean by clinical and research instrumentation. So the concept of man instrumentation system, it is applicable to both clinical as well as research instrumentation system. Now, the human body contains different types of systems, right? Now, actually, when we study a human body, it's a very complex system actually. All all engineering branches are involved in human body. So there is electrical engineering, there is mechanical engineering, there is acoustic engineering, there is a thermal engineering, there is a chemical, is there, hydraulic, pneumatic, optical, computer is there, our brain and the nervous system, then communication, the way we communicate, right, then control. So all these engineering branches are involved in the functioning of our human body. So that's why it becomes very complex. So these are the various systems which we study to analyze and find out the behavior of our human body. The inputs for all these systems, the inputs we consider are vision, hearing, smell, taste, inspired air, and sensation, liquid intake, and the food intake. There may be many more. So these are the different types of inputs which are given to this complex system. We call it as the human body. And it processes all these types of inputs and it produces the outputs like identification. So we recognize something based on the sensation. Speech, based on the input, we process it and accordingly we speak something. Behavior, then appearance, expired air, liquid waste, food waste, and many more. So these are various outputs which are which appear at the output of this complex human system, which is combination of all these various systems as we discussed just now. Okay. Now, the block diagram in the previous slide, we can divide it into some more blocks like this. Now, in this case, these are the inputs: vision, hearing, smell, like that. Okay. Now, this input, for example, if I am speaking, so it is a voice input, right? Now, this voice input, it is to be sensed by the brain, right? And you know, brain, it works on the electrical signal. So that means the voice signal, it must be converted into electrical signal. So it is just like a transducer, converting one parameter into converting the parameter from in one form to the other form. So transducers are involved here. So these are the different types of transducers, right? And the stimulus are the inputs. So stimulus means audio, video, or maybe mechanical, vision, and so on. So what are the inputs are given to the body? That is the stimulus. Transducer which convert the stimulus, which convert the input into electrical signal, because the input can be optical, that means vision. When we see something, it is the optical input, right? It can be audio when you hear something, or when we sense something with the help of our touch. It can be sensory input, and so on. So these transducers convert the different types of stimulus or the input into electrical signal. Now, once it is available in the form of electrical signal, then it is given to this signal processing equipment. So the signal processing equipment, it is just like a computer. It will process this. It will process this and it will display at the output. This is the instrumentation system. So display, it may be screen or it may be some digital display like that. Okay. Some part of the output from the signal conditioning, it may go to input again for the sake of feedback. And in between, we can store this data, record this data. So there is a recording, data processing, and the transmission of data. If the data is to be transmitted at some other place, then transmission is also involved. So this is, in general, the components in man instrumentation system. Okay. So these are the same things what we discussed in the previous block diagram. It consists of stimulus, that means the measurement, transducers or the sensors, signal conditioning, that means it may be signal processing or some amplifiers. Then output devices, maybe alarms, display, data storage, data transmission or data recording, and it may have some control system. So these are various blocks involved inside this man instrumentation system. Okay. Now the factors. Now see, this is not a conventional instrumentation system because the living organism is involved in all these measurements. So there are various factors to be considered while obtaining reliable and meaningful measurements. Measurement should be reliable and meaningful. That means we should be able to draw some conclusion from that. So what are those factors? No danger to the life of the person. So when these measurements are being taken, while designing the equipment, we must ensure that the equipments are not dangerous while being used. No undue pain There should not be pain, discomfort, or any undesirable conditions while making use of these equipments. And all the necessary safety factors are should be considered while designing these equipments. Okay. Then the hospital environment, whether the equipments are suitable for use in hospital environments. And while making use of these equipments, the medical personnel must be involved because they know, they have study of the medical field, actual body parameters, what is happening to body. So while making use of these equipments, the medical personnel must be involved. So these are the factors while considering designing our equipments for carrying out measurements with living organisms. Then ethical and legal considerations. Whatever the measurements are being carried out must be within the law of the country. Now you may ask question how these measurements are involved with the legal things. You must be aware sonography we cannot use to find out the type of sex, male, female. It is not permitted anywhere in our country. Okay, so that means legal things are also involved while making use of the equipments. So these are the various factors. Now, what are the objectives of this instrumentation system? Why do we use the electrical or the electronic equipments in case of medical field? To gather information, to gather the data related to the health of the people, diagnosis of the disease, we make use of the equipments, evaluate certain parameters to draw a conclusion so that the doctors will be able to make certain decision what type of treatment to be given. Monitoring purpose, to monitor health of the person. Okay, so and control, sometimes they are used to control also, depends on the type of equipment. Okay, so these are the basic objectives. Why do we use the man instrumentation system? Now, while designing this medical instrumentation system, uh, the design criteria or the factors to be considered while designing a medical instrumentation system are quite different as compared to the design of our regular instrumentation system, conventional instrumentation system, because here the living organisms or human beings are involved while working with these instruments. So what are those constraints? The very important constraint is the measurement range. Now, when you have studied instrumentation in case of any other subjects in our electronics engineering, you might have you might have performed various practicals in our laboratories, CRO, the voltmeters, ammeters. You might have used right. Digital meters, analog meters, and you worked with various circuits. You use those instruments to find out voltages, currents in various circuits. Okay, so you already are familiar with that, right? But the similar, you cannot use the similar type of equipments to measure the voltages inside our body, or in general, you cannot, the conventional equipments cannot be used for carrying out measurements with living organisms. So we are discussing what are those constraints. So the very first constraint is the measurement range. See, uh, we'll study later that in our human body, various types of electrical signals are generated, right? And you must be aware of this. But when you touch each other or any other object, you do not get shocked when you touch your friend, when you shake hand with your friend. You do not get shocked because of the electricity in the other person, right? This is because the amplitudes of these voltages, actually it's very small. Most of the times it may be in microvolts. Okay. Now, when these voltages are in microvolts, it becomes, it becomes very difficult to measure and work with this type of voltages. So that is one of the challenge while designing any instruments for medical applications. So the voltage level is very small. So now when the voltage level is very small, obviously lot of noise gets involved in that. Okay, so that is one of the important measurement range. Okay, now at this point, I would like to ask some question to somebody. Okay, now there is one question to you. You might have heard there are some voltages when like EEG, electroencephalograph, that is the when we connect electrode at the scalp, uh, it measures the signals generated by our brain. Okay. Now, can anybody tell me what might be the range of frequencies of those signals? Everybody knows some electrical signals are involved while with the help of some electrical signals are involved related to our brain. So any idea about what might be its frequency range? Can anybody tell me? You can unmute, somebody can unmute and speak. I'm waiting for the response. There are 16, 15. One is myself. Are you there online? Or just simply logged in? Because I do not want the complete 1 hour lecture one-sided. I keep on speaking and without having aware that whether you are there or not. I'm waiting for your response. Somebody can unmute and speak. Sonali, Renuka, Dipali, Vajanti, are you there? Okay, should I continue or stop? Without response, it's difficult for me to speak. Komal, Roja, Akshada, Neha, Rupali, nobody is there. Should I wind up and declare that What a topic I wanted to cover today are over. Okay, somebody has given some message. Okay, it's about attendance only. I am asking some questions to you. I need some response. Otherwise, it will be difficult for me to continue. I will mark everybody absent in that case. There is no point in speaking to machine. Okay, yeah, somebody answered. Okay, Neha, 50 to 60 hertz. Thank you, Neha, for responding. I think others are taking sleep. Anybody else? Neha is saying 50 to 60 hertz. That is the brain frequencies. Okay, Neha, can you speak by unmuting? Why do you think it's 50 to 60 hertz? Logic? Or
I have read it in somewhere.
okay. Yeah, you read it somewhere?
Yes, sir.
Okay. No, actually, this 50, 60 hertz, it is quite high. Yes, somebody has answered correctly. Okay, Vaijayanti. Is it your answer or with the help of Google? Vaijayanti, all answers, it's perfect answer.
Sir, I have searched it right
Yeah.
now.
Okay, very good. No issue. Okay, Vaijayanti has given the answer in the chat box. See, when we are performing various activities, the signals, electrical signals generated by our brain are different, right? So, as she has mentioned here, delta, theta, alpha, beta, and gamma. Gamma is the highest frequency. Okay. Now, it normally it will be in alpha or theta, right? Delta means when you are asleep or you are in deep meditation state. That will be delta. So people who are very quiet and calm every time, usually their brains will be working at lower frequencies. And when you are excited, the frequencies increase. Okay, that's it. Okay, so let us proceed for our. Okay, so right now, as you have seen the frequency range, uh, again there is a question to you. uh, these type of frequencies what you have typed here. Okay, Vaijanti, I am again over to you. Okay, delta is 1 to 4 hertz, theta 4 to 8 hertz, alpha 8 to 12 hertz, right? Now out of this, which frequencies you can measure easily using our equipments in the lab? Usually you use CRO, right, Vaijanti? Okay, yeah, now my question is, out of this alpha, beta, theta, gamma, which frequencies you can easily measure in the lab? Because you have operated CROs, so your CRO, the when you to observe the signal on the CRO for measurement purpose, the measurements are accurate when the signal frequency is less or higher. That is my question. On CRO, when you perform experiments in the lab, you find that reading it is more reliable for lower frequencies or higher frequencies? I want answer. Higher frequency, yes, correct, right. So that is the problem here. Okay, let us come to our topic now. As Vaijayanti has mentioned, the frequency range, see, the second constraint while working this electronic equipments for medical instrumentation purpose is the frequency range, because as just now we have seen, the frequency range, it is very less. In most of the cases it is a low frequency, right? And the carrying out measurement at low frequencies, it's challenging and it's difficult. Okay, so while designing equipments for medical applications, these are the challenges or the constraints you have to face. So measurement range, that means the amplitude, it is in very small, and the frequency is also very small. Okay, now apart from these two constraints, there are many more. Like, okay, so I'll just read one by one. Variability of physiological parameters, right? Now, what do we mean by this? Physiological parameters, variability. Variability means every time you measure, the reading might be different, right? This does not mean it is wrong, because our body, it's a very complex system. Okay, so for same input, you will not get the same output. Okay, for example, if you pinch your friend, so for pinch is the input. When you are pinching your friend, output will be different, right? So that means variability of physical parameters, right? Then the interface among physiological systems, interface will be different. Transducer interface problems. See, to carry out the measurements, you will have to use the transducer, and that transducer you have to apply. For example, if I want to measure the signal from the brain, then I will attach some electrodes on the brain here, right? So I cannot simply put the electrode on my head and it will not give directly, it will not give signal, right? Because it is to be properly interfaced. So there are interfacing problems of these transducers, right? And there is a high possibility that it will acquire noise from various sources, that means artifacts. Okay, then the safe levels of energy. So when you are using the electronic equipments, many times they will use their own energy. Some voltage will be available in that electrode, right? So it should be within the safe levels. You should consider all safety considerations. It should be reliable. Then while designing the equipment, you should consider that human beings are going to use those equipments. So the measurements are being carried out with human beings, right? And all government rules and regulations must be followed. So these are all various different constraints while using this medical instrumentation system. Okay. These are some general considerations while designing the medical instrumentation or the man instrumentation system. General considerations are the types of sensors to be used, its sensitivity, the range of the equipment, that means low frequency, high frequency, whether it is able to measure low voltages and so on, the input impedance, frequency response of the equipment, accuracy, linearity, reliability, whether you need differential or the absolute input. Differential input means in case of instrumentation amplifier, you know it works on the differential input. So whether you need differential or the absolute input. Okay. Then environmental considerations like signal to noise ratio, whether it is able to work in the noisy area, stability, atmospheric temperature, pressure, humidity, vibrations, radiations, etc. Okay. Then medical considerations, that means whether it is invasive or non-invasive technique, whether it is invasive or non-invasive. Now, what do you mean by this? Invasive or non-invasive? Invasive means it is going to directly interfere our human body. Okay. That means when you for the purpose of measurement, if you are inserting any needle directly inside our body, that is invasive. Okay, if you are taking measurements without disturbing body, without touching body, then it is a non-invasive technique. Then it is non-invasive technique. So there are some equipments which are non-invasive and some equipments which are invasive. Okay, so in now obviously everybody will prefer that the equipment should be non-invasive, but many times practically it is not possible to carry out measurements every time using non-invasive techniques. Okay, for example, you might have heard endoscopy. So in case of endoscopy, there is a what happens, suppose in your stomach there are some ulcers, and the doctors, they want to see what is the position or condition of those ulcers. Then they use one catheter, and at the end of the catheter there is a camera, and that camera, it is inserted in the mouth and then through our esophagus, right, from our throat, it goes to the intestines, and doctors, they directly watch through the camera what is there inside the intestine. So obviously this is a invasive technique, because directly that camera is inserted in our body. Okay, but sometimes there is no option for this, right? Why this is important? Because it is related to the discomfort of the patient. Then there may be some radiations or maybe heat dissipation, electrical safety involved, right? Toxicity, and so on. So these are the things to be considered. Then economic considerations. So the initial cost, it should be less, and the cost and availability of consumables, that means the spare parts, that is also the criteria while designing this equipment. So these are the general considerations while designing this. Okay, then I will just list out the different types of recording instruments. Electrocardiography. So this, usually most of us know this. This is to carry out to find out ECG, to measure ECG, electrocardiograph, that is related to our heart. Okay, then electromyography. So this electromyography, this is related to the electrical activity in our muscles. So it is called as EMG, electromyograph. So because our muscles also work with the help of some electrical activity, electrical signals. So the electrical signal available at our muscles, it is electromyography. Then electroencephalography. So this is our brain signals, EMG. So it is the measurement of brain signals, electroencephalography. Okay, then it is expirography. So this expirography, it is about the respiration. That means how much, when we inhale and exhale, how much air we take as input and how much air is given at the output. So measurement of that, that is expirography. Then phonocardiography. So when you see this word here, cardio means it is related to heart, and graphy means plotting it, plot the graph, and phono means it is about the sound. Phono means it is about the sound. So plotting the sound signals generated by our heart. Okay. Now, if you are listened carefully, you can listen to the sounds generated by our heart when the heart is carrying out its pumping action. Right? You might have seen stethoscope. The doctors, they use stethoscope, and it's a very ancient and old technique to which is useful, which is one of the equipment doctors use for diagnosis purpose. Stethoscope. Okay, so that is actually they listen to the sounds generated by our heart. And if you use any electronic equipment to plot the graph of the audio signals produced by our heart, that is phonocardiography. Then next is plethysmography. So this plethysmography, this is related to the volume. Okay, so that means suppose you know, in our body, human body, there is a blood, and blood is circulating inside our body. And as per my knowledge, I think 5 to 6 liters of blood is there in our body, and that keeps on circulating. Okay. Now, in some of the cases, doctors they want to find out what is the volume of the blood in our body and how it is circulating. That means the changes taking place in the volume of the blood. Okay, so and this may be related to volume of air also. So those type of equipments are called as plethysmography. Then thermography. Thermography means thermal. Thermo means related to the heat, that is thermal, and graphy means plotting it. So it's the thermal graph. What is the temperature at each and every point inside our body? So those, it is also available in the form of images. We call it as thermal images. You might have heard it. So that is thermography. Then tomography. Tomography, this is something taking slices or cross sections of a three-dimensional object. Okay, you might have seen many times some pictures, you might have seen photographs where doctors, they use some cross section of a three-dimensional object in our human being. For example, if doctors want to study the behavior of the heart, then they may use the image as a cross section of the heart. So this can be measured with the help of equipment. CT scan is one of that example. Okay, so tomography. So it is actually taking a slice of a three-dimensional object. Then ultrasonography. This usually we are familiar with this ultrasonography. So this sono means sound, ultra means it is the frequency. So we plot a graph based on the sound signal. So that is ultrasonography. Then radiograph. So that is X-ray. So you know all, we are familiar with this. Okay, so these are various recording instruments, electronic equipments we use to record various electrical parameters. Okay, but in our subject, we will be studying in detail only about these two, ECG and ENG. So we have one separate unit for ECG and one separate unit for ENG related to brain. So all these different types of signals are there, but we'll be studying only the signals related to brain and related to heart and how to process those signals. So that is our subject, and that is the purpose why I have listed all these recording instruments here. Okay, some more constraints in medical design, medical instrument system designs. Okay, the signal to be measured inflicts limitations on how it should be acquired and administered. Also, the frequency range of a signal strength is much lower. So this already we have discussed about the frequency signal. Now, one important point here is how the signal to be measured is acquired and how it is administered. Right. Now, what do you mean by administered here? Now, sometimes in some part of the treatment, some electrical signal is given externally to the body. Right. So in that case, you have to be very careful about what type of electrical signal you will be giving. So your medical instruments must be designed accordingly. Then the interference or the crosstalk between different organs. Okay. For example, when you are measuring brain signals, your electrodes may measure some signals from the other organs like our muscles or heart and so on. So you should consider crosstalk between different organs. We'll study in detail about this later. Okay. Then the placement of the sensors. Now, when you are acquiring the electrical signal from the brain, right? Now, it is very important where exactly I should place the sensors. That means the location of the sensors on the brain or on the heart. So it's very important. We'll see those things in detail later. So the placement of sensors is important. Okay. Safety, obviously. Then the operator's expertise, the person who is using the particular equipment must be expert. You must know how to handle those equipments, must be properly trained. Okay. Then measurement variability. So you should consider the practical things. That means the same equipment when used on the same person may give different readings at different times, right? Because where various changes are taking place in our body, there may be different the fluid level or the liquid level inside the person. It may be different at 3 o'clock in the afternoon. It may be different in the night at 5, right? That means 5 a.m. and so on. So you must consider this measurement variability factor here. So that's it. So that is about the introduction of instrumentation system. Okay, man instrumentation system, what we have discussed today. Next time, we'll discuss about the biopotentials. So what are the different types of electrical signals produced in our body and how they are actually generated and what are their characteristics, what are the amplitude levels and so on. And based on that, what are the different types of electrical signals? How do we classify the electrical signals? So that we'll see next time. And then after that, it will be in the further lectures. Then the electrodes also we are going to study in this unit number 1. What are the different types of electrodes used to carry out measurements of all these electrical signals? Okay. So next time we'll see the origin of biopotentials. So what do you mean by biopotential? How the signals are generated inside our body and what are their characteristics and so on. So that we are going to study in the next lecture. Okay. So that is for today. Again, for latecomers, if you have not typed your roll number in the chat box, please type your roll number in the chat box for attendance purpose. If you have done it already, ignore this. Okay. And if anybody has any question, I will wait for a few minutes to answer the question. Any queries, any questions you have? And the recording of these lectures, it will be, I'm recording all my lectures and this recording, it will be available on Bodhi Tree. So within 1 or 2 days, I will make available a Bodhi Tree platform for biomedical signal processing. So if you have missed any lecture, you will be able to listen this again, or at the time of exam also it will be helpful for you. So all these recordings will be available there. Okay. Do you know how to use Bodhi tree? You must have used it. Have you used Bodhi tree for some other subjects earlier? Are you familiar? Okay, okay, fine. So these recordings, and if there are any books, PDF copies are there, or any lecture material, everything will be available on Bodhi tree. After it is ready, I will give you a message in our WhatsApp group when my Bodhi tree course becomes ready. Okay, so that is for today. So good day to all of you. Let us stop here.